Uh, Good day, people. Welcome once again to this page. Today I'll be teaching you how to plot a cumulative frequency curve. Cumulative frequency curve. Cumulative frequency curve, also known as ogive. Ogive, also known as the ogive. Now it is the plotting of the cumulative frequency on the vertical axis. On the vertical axis, you have the cumulative frequency. Cumulative frequency on the vertical axis, while on the horizontal axis you have the upper class boundaries. The upper class boundaries. I believe you all know what the upper class boundary is. If you have say 0.5 to 10.5, 10.5 to 20.5, 20.5 to 30.5. Now all these are the lower class boundaries called L1, while all these are the upper class boundaries called L2. So the cumulative frequency curve, or the ogive, is the plotting of the cumulative frequency on the vertical axis and the upper class boundaries on the horizontal axis. So I want us to solve an example to illustrate this. Now look at this example. The table shows the distribution of, let me see if I can zoom this out a bit. Now the table shows the distribution of marks scored by some students in a test. That's marks, the number of students, that's your frequency. Now what we'll do is we prepare let's just construct a cumulative frequency table for the distribution, draw a cumulative frequency curve for the distribution, use your curve to estimate the median, lower quartile, upper quartile, semi-interquartile, range, decile and percentile. And we do this now. The marks, let's start with the marks. The marks, the cumulative frequency, the class boundaries, or better say, let's put the class boundary and the cumulative frequency side by side, so it becomes very easy for us. Now the frequency is, remember, it's the number of students. Then here we have the class boundaries, and here we have the cumulative frequency. So here we have 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, 91 to 100. Now for the frequencies we have 3, 17, 41, 85, 97, 115, 101, 64, 21 and 6 and 6. If I can zoom this out a bit. Okay, good. Um, Now for the class boundary here we subtract 0.5 here, we add 0.5, subtract, add, subtract, add, subtract, add, because so here we have 0.5 to 10.5, 10.5 to 20.5, 20.5 to 30.5, 30.5 to 40.5, and here 40.5 to 50.5, 50.5 to 60.5, 60.5 to 70.5, 70.5 to 80.5, 80.5 to 90.5, and finally 90.5 to 100.5. Now for our cumulative frequencies, and again, please, before you do this, I omitted this. You can leave this first page blank. You can call this 0, 0, 0, because the graph has to start from 0. It has to start from the origin. The graph must start from the origin. Okay, so for the cumulative frequency, the first digit is, the first frequency is 3, so put 3 here. So 3 plus 17 is 20, right? 20 here. 20 plus 41, that's 61. 61 plus 85, that's 146. 146 plus 97, we have 3, carry 1, 10, 14, 4, carry 1, that's 2, 43. 243 plus 115, we have 8, 5, 3, 358. 358 plus 101, we have 9, we have 5, we have 4. 459 plus 64, we have 3 here, 6. 6 plus 6, 12, 2, carry 1, that's 523. 523 plus 21 gives us 4, 4, 5, 544, that's 5. 544. Then 544 plus 6, that's 550. So that gives us 550. Now let's plot this. We'll plot this now on the vertical axis. Remember, we are plotting this on the vertical axis. We are plotting this on the vertical axis. Then on the horizontal axis, we are plotting the upper class boundary. These are the upper class boundaries. These are the upper class boundaries. I'll be showing you how to plot them shortly. So we are plotting this on the vertical axis, then this on the horizontal axis. So let's continue. Now we can use a scale of, we can put it in 50s. We can calibrate our vertical axis in 50s. Yes, in 50s. So this is our graph here. Let me zoom it out a bit. So this 50, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are left with one more point. Okay, let me turn it upside down. Let's see the number of points we also have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. Then on the vertical axis we have here let me see, 550. We can have 1 2 3 4 5 6 7 8 9 10 11. Okay, very good. So we can start plotting our graph from this point. So with your ruler you can rule this point like this. Please ignore what I'm doing here. Please just ignore the errors. I'm not using a perfect tool. So this is our horizontal axis. So this cumulative. So this is cumulative frequency. Cumulative frequency. Why this is upper class boundary. Upper class boundaries. This is 0. So the first point starts here. It has to start from origin. Then this is 50, 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. Then this is 550. This is 550. Then this is, now we are using the upper class boundary. The first upper class boundary we have here is, let's see, the first upper class boundary is 10.5. So we're running from 10.5 to 100.5. So this is 10.5. This is 20.5, 30.5, 40.5, 50.5, 60.5, 70.5, 80.5, 90.5, 100.5. Our graph cannot contain it, but let's just improvise. We improvise here. We improvise. Please, let's just bear with me here. My graph, I should have used this point. Okay, I can still do that. It's just that, yeah, now I've done that. Magical, right? Okay, good. Now let's start plotting. The first point there is the origin. The first point must start from the origin here. Then the next point is this. When it's 10.5, the cumulative frequency is 3. When it's 10.5, cumulative frequency of 3, that's somewhere here, just somewhere here. Then at 20.5 is 20. Look at this. At 20.5, it is 20. At 20.5, class boundary of 20.5, the cumulative frequency is 20. So at 20.5, 20 is let me see, 5 10th here. That's at this point exactly. Then at 30.5 we have 61. At 30.5 we have 61. This 50, 55, 61 should be somewhere here. Let's just say somewhere here approximately. At 40.5 we have 146. 146. That's this 100. That's here. That should be this point. At this point, then 50.5 is 243. 50.5 is 243. That's this 200, this 250, 243. That's somewhere here, somewhere there. Then 60.5 we have 358. At 60.5 we have 358. 358 is this 350. 358, a bit above 350, that's there. Then at 70.5 we have 459. 459, that's like that. 459, this 450, that's here at this point, somewhere at this point. 459. At 80.5 we have 523. 80.5 we have 523. This 80.5 here, so 523 should be this point here. 523. 523 should be 1 2 3. Let's say this point. Then 90.5 will give us 544. 544, that's at this point. 544. 5 10 15 20 544, that's here. Then 100.5 will give us 550 at this point here. Now we join all the points. No point must be left out. Let me use another color to join it. Let me use say green. Okay, good. So we start joining. We join all the points. Use your French curve to join all the points to produce. You should get a smooth curve. Use your French curve to join all the points so produced. If you have a broomstick, and join all the points. All the points must be joined. All the points so produced. So these are cumulative frequency curve. See how it goes. Now let's answer the questions that follow, because that's the most important thing. If you plot the curve, you should be able to answer the questions that follow. Now the first question here says the first question here says, from your curve estimate the median. So number one, the median. The median is given by n over 2 of the entire distribution. N over 2 of the entire distribution, that's 550 divided by 2, that's 275. Now from the curve, from the ogive, or the curve from the ogive, that's this curve, 275. Let's trace 275. 275, this 250, 275 is, each of this is 50 units, so 275 should be, that means each of these lines should be 5. 250, 255, 260, 265, 270. 275 should be somewhere here. So use your ruler and trace it to the curve. So wherever it touches the curve, you stop, then you trace it down. It's at this point, then you trace it down. That's what I'm doing now. Trace it down. Is at this point. So this is 50.5, 51.5, 52, 53, 54.5. From the ogive, the median is equal to 54.5. 54.5. Okay, let's continue. The next question is the lower quartile. Number 2, the lower quartile. A quartile divides a distribution into 4 equal parts. You have the first quartile, the first quartile, also known as lower quartile. You have the second quartile. Second quartile is the same as median, so they will hardly ask you for second quartile. Second quartile is the median. Then you have the third quartile. you have the third quartile is the upper quartile. It's the same as upper quartile. Then the fourth quartile is the entire distribution. The fourth quartile is the entire distribution. That's the 100%, the entire distribution. Now back to our question. Lower quartile. Lower quartile. That's n over 4. N over 4 of the entire distribution. So the lower quartile is 550 divided by 4. 550 divided by 4, that's 1 3 1 3 7 point, let's see, 550 divided by 4, 137.5, 137.5, 137.5. So from the curve, 137.5, that's around this point. Let's see, that'll be 1 2 3 4 5 6 7, that's somewhere here. 137.5 is somewhere here. So trace it. Wherever it touches the curve, you stop and you bring it down. Here, that's here. Then bring it down. That's this point here, which is what, 40.5 from the curve. Lower quartile is equal to 40.5. Then the next question here says, after the lower quartile we have upper quartile. The upper quartile. Upper quartile is 3n over 4. This is how it's gotten. 3n over 4. That will be 3 times 550 divided by 4. That gives us 0 5 1650 divided by 4. That gives us 4 1 2 point 5, 412.5. So from the curve, let's see, 1650 divided by 4, that's 412.5. 412.5. Now 412.5 from the curve. That will be, let's trace it. 4, this 400, 412 is 412 somewhere here. Please know that this is an approximate value. If you do this with a real curve, with a real graph, you should be able to get accurate values, more accurate values than what I have here. So this is just for illustrative purpose only, although it will be close to the answer you get with your graph paper. So we trace it down. Tracing it down gives us, let me see, let's follow that line down, trace it down. I hope I'm still on track. It gives us here at this point, that's 60.5. 1 2 3 4 5, that's 65.5. So from the curve is equal to, from the curve, the upper quartile is equal to 65.5. The next question says semi-interquartile range. Semi-interquartile range. Okay, I think I've, oh my god, let me clean this. 65.5. So from the curve, it is from the curve, upper quartile is equal to 65.5. And for the semi-interquartile range, Look at this now. Interquartile range. Interquartile ranges is Q3 minus Q1. I forgot to state this. Now Q3 upper quartile is Q1. Lower quartile, not upper quartile. The lower quartile is Q1. It's represented by Q1, while the upper quartile is Q3. Now interquartile range is given by Q3 minus Q1. Now semi interquartile range. Semi interquartile range is Q3 minus Q1 divided by 2. Q3 minus Q1 divided by 2. Now our Q3 is 412.5. We already have that. 412.5 minus Q1 is 65.5. No, sorry. Our Q1 is 40.5. Our Q1 is 40.5. While our Q3 is 65.5. So Q3 minus Q1, that's 65.5 minus 40.5 divided by 2. That gives us 25.5 divided by 2. That gives us 12.2. 25.5 divided by 2. 12.75. 12.75. That's our semi-interquartile range. Now for the decile divides a distribution into 10 equal parts. Now the decile is 10, 550 divided by 10. That's 55. So 55 from the curve. From the curve is okay, let's trace it now. 55 from the curve is 50. This point here. Then take it down. That's 30.5. So from the curve is 30.5. From the curve, decile is equal to 30.5. Now percentile divides into 100 equal parts. Percentile divides into 100 equal parts. So 550 divided by 100. Percentile is that. 550 divided by 100, that's 5.5. 5.5. So you go back to the curve and trace it. Whatever it gives you, that's your answer. So I think we have to stop here. Thank you for your time. I look forward to meeting you in our next video. Bye.